This video is going to be about membrane potentials. So a membrane potential is voltage across a membrane. So in our bodies, the inside of our cells are negatively charged compared to the outside of our cells. So how do we get this difference in charge on either sides of this membrane? Is we get it through something called electrogenic pumps. So the most important electrogenic pump in animals is going to be the sodium-potassium pump, which we already know how this pump works from the video on active transport. So just to review very briefly, it's going to pump sodium outside of the cell, and it will pump potassium into the cell. And so that's going to help generate these different charges on either side of this membrane. In animals, in plants, and bacteria, they use the proton pump instead of the sodium-potassium pump as their main electrogenic pump. So now we have this high concentration of sodium on the outside of the cells. So let's say now that we open up a sodium channel. So when we open up a sodium channel, sodium is already going to want to flow down its concentration gradient from high to low. But in addition, now sodium is going to be attracted to this negatively charged environment on the inside of our cells. So not only is it going to be moving down its chemical gradient, it's going to be moving down its electrical gradient as well. And so when we combine these two gradients, we call it our electrochemical gradient. So the electrochemical gradient is very important for the movements of any kind of ion, whether it be into or out of the cell. So we can change our definition of diffusion for an ion, and instead of an ion moving down its concentration gradient, change that to it's an ion moving down its electrochemical gradient. Whether that be inside the cell or outside the cell, it doesn't really matter. As long as it's flowing down its concentration gradient and its chemical gradient, then it will be flowing down its electrochemical gradient as well. I hope you found this video really helpful. The concepts and information presented in these videos will be true regardless of what biology course you're taking. However, the material we covered in this video is specifically referencing material covered in Campbell Biology's 11th edition. Remember that if you are an enrolled Baylor student, we do offer free tutoring on the first floor of the Sid Richardson building, and you can schedule a free 30-minute appointment to have one-on-one tutoring online, or you can stop by during any of our business hours. For more information about the services we provide, you can go to our website at www.baylor.edu/tutoring. Thank you.